And we're solving equations. Start you off with a couple of different parts here. And because everything we're doing so far has been rational fractions, that means we're going to have fractions in the equations that we're solving. Okay, now that we're doing addition and subtraction in this thing, you still have to do the same thing we were doing before when you had addition or subtraction with fractions. You still have to find the least common denominator. So it doesn't matter what you do. If you're adding and subtracting, you still have to find the least common denominator every single time. The good news is there's only two numbers you have in your denominator. It's 3 and 4. So start going by 3s and 4s. The first number they have in common should be 12. Now, here's where we're going to change up a little bit, though. This is where we're going to do it more like the complex fractions. Once you find the least common denominator of 12, instead of rewriting everything with that common denominator, we're going to multiply everything by that common denominator. And that's why they kind of put the complex fractions right before we do the solving equations, because they're similar, because once you find the least common denominator, you do not rewrite them, you multiply by that common denominator, and now all the fractions are gone, and everybody's happy because nobody likes fractions, right? Just call it like it is. So we're going to take 12 and multiply it by every single term that's in here. Now, and because you have the fraction, some people spray. Everybody, watch out. Put that over 1 when you have the fraction. Well, we don't have a fraction there, so you don't have to worry about it for that part. But most people like having that other fraction to go with it when you have a fraction that you're multiplying by. So if you're multiplying a fraction by the whole number and you'd rather have it so that you've got a fraction in the fraction, some people just kind of like doing that to see it so it kind of matches up a little bit better. And again, we didn't need 12 over 1 as a fraction because the 4x was the whole number. Go through that. Now you should be able to cancel. 4 going to 12 3 times. 3 going to 12 4 times. That's a whole number, so we're good there. And for this one, 4 going to 12 3 times. And now everything should be whole numbers. Or if at worst, you've got a fraction over 1, which should be okay. Multiply it together. You've got 3 times negative 5. That is negative 15x. You've got a negative 2 times 4 for negative 8. 12 times 4x is a 48x. 3 times 3 is 9. And now you've got something that is nowhere near as complicated as what we had because it's all whole numbers. And with all whole numbers, most everybody's happy. So now we'll just move the x's to one side, numbers to the other, and just see what you have for an answer. I usually like to work with the negatives. Get rid of the negatives first. So if you've got a negative 15x, that way we can add 15x to both sides. So it's negative 8 equals 63x plus 9. And since the x is over here, let's get rid of the 9 and move it over to the other side. And once you do that, you've got 63 times x. So to solve this equation, we're going to divide both sides by 63. So your 63's canceled. 17 over 63 is a fraction. And there's really nothing you can do to simplify that one, so that would be your final answer. And negative 17 over 63. Negative x equals, yeah. Okay. And the whole thing we're going to do throughout all the parts when you're solving, if you've got those, you're going to do the same thing every time. Find the least common denominator, multiply all the terms by the least common denominator, and depending on the numbers, sometimes you get fraction answers, sometimes you're going to get whole numbers. It just depends on the numbers they throw out to you. Oh, okay. Multiply, find the least common denominator first. Multiply all the terms by the least common denominator. And then once you've done that, now you've got just an equation without fractions. Just solve that equation. Okay, same type problem, just a little different look to it. Let's go with 9y plus 1 over 3 minus 5y minus 3 over 6 equals 3. And again, this one goes pretty quick. You got 3 and 6 in your denominator. When you start counting by 6s, or count by 3s, you get 3, 6. So there's your least common denominator. It's got to be 6. So again, we're going to go back and take every fraction and multiply it by 6. Or sorry, take every term. Now, it doesn't matter whether it's a fraction or not. You're going to take every single term, multiply by 6. Again, if you're going to put these over 1 because they're fractions that you're multiplying with, you can do that. And at the end, we've got 3 times. That's a whole number, so you don't need the fraction for that part. Just leave it as 3 times 6. And once you multiply through by the least common denominator, every fraction should be gone. It should just be whole numbers that you're working for. So for this one, 3 and 6, 3 will go into 6 2 times. This one, 6 will go into 6 1 time. And that one will just multiply it together. So now, here's where you got to be a little bit careful. You've got 2 times 9y plus 1 minus 5y minus 3 times 1. And then 3 times 6 is 18. Okay, now, here's where you don't want to get in too big a rush, because sometimes people will see the 2 and they'll go, oh, I'll just do 2 times 9 and make it 18. It is, but it's also 2 times 9 and it's 2 times the 1 that you've got to do distributive property, because that whole expression, just like this one, is considered in the parentheses with it. So, doing distributive property, you've got 18y plus 2. And this one, you're doing 1 times this one, but again, it's the negative that's in front. So it's negative of 5y. But it's also the negative of minus 3. So that would make it a plus 3. Well, technically, since you're going to multiply the terms, it'd be like distributive property, that technically you're doing 6 times 9. And you're doing 6 times 1. But once you do that, you're going to divide them by 3. Right. So if you just do that part first, you're taking 3 divided by 6. So really, instead of doing distributive property with 6, you're only going to have to do it by 2. Because you're going to go back and divide every... Yeah. Yeah. Okay. And again, that one with the minus sign sometimes gets a little bit sneaky, because when you cancel this out, you can really move the 1 in front. So it's negative 1 times 5. And then negative 1 times negative 3. Alright, so from there, now we've got all whole numbers. You've got basically that you can combine like terms on this side. You can do 18 minus 5 and make that 13y. You've got 2 plus 3. Make that 5. And again, they're on the same side, so you don't have to change any signs or do anything weird with it. If they're on the same sides of the equation, you can just put them together just like they are. You don't have to change any signs. When you have to change the signs is when you move it from one side to the other. So we've got the 13y plus 5. Now we're going to get rid of this negative 5. And we're going to move it from the left-hand side and move it over to the right-hand side. So that's why we've got to change the sign there. And then you've got 13y equals 13. Divide those two numbers. So you should have y equals 1. Okay, so first couple problems, again, just having you solve an equation, working through these. They change it up just a little bit. I made this on example 3. Because this one, you are solving, but I should ask you to solve. Let's see how this here. It says solve a rational equation. Instead of finding a certain value, instead of finding x equals 2 or whatever you're looking at in this case, again, just kind of looking at the objective that tells you. So solving a rational equation that simplifies to linear. And then they're going to give you an equation, and they're going to ask you to go into the solve for u part. So the other ones, it's still pretty much the same thing. You know, you've got this fraction you're going through, you're working through, find the least common denominator. This one's a little bit different. You can still do it the same way. So you got negative 8 is equal to negative 5 over u minus 8. And sometimes they'll explain it a different way, but for this one, let's stick to the same way for this thing. Go ahead. What is the least common denominator? What is the only denominator? U minus 8, right? So in that case, your least common denominator is the only one you have, so it's got to be u minus 8. So you're going to do u minus 8 times both, all the parts of 2. Okay, the only thing you can cancel is the only fraction you have here, so you can cancel this u minus 8 with u minus 8, and again, you're basically putting 1s in its place. So now you've got negative 5 times 1, which is just negative 5. On the left-hand side, you're still doing u minus 8 times the negative 8, so again, it's another distributor property. It's 8 just happens to be in the back side, on the back side instead of on the front. But it's still negative 8 times u for negative 8u. And then negative 8 times negative 8 for a positive 64. Okay, so once you've done distributor property, you've already got the u's by itself here, so let's get rid of the 64. So that would leave you with a negative 8u equal to a negative 69. And just putting that answer back over here, so we're out of room. You're going to take the negative 69 and divide it by negative 8. So you got a negative over negative, which makes that a positive 69 over 8. Okay, same setup, same type problems, just a little different look to it. Because for this one, we've still got the same thing. It still says to solve. The biggest difference on this one is now instead of having a number in your denominator, you've got a variable. But it's still the same thing. The good thing for this one is there is only one denominator. So when you find your least common denominator, if that's the only one, that's got to be your least common denominator. So now we're going to multiply everything by b instead of 2 or 6 or 4, whatever it was we were doing in the earlier problems. So we're going to take the original problem we've got. We're going to take the 4, and we're going to multiply it by b. We're going to do the plus 40 over b. Multiply it by b. Equals 9. And if you want to put the 4 in parentheses back here, you can. Multiply it by b. But everything you had in the original problem, you can go back and put parentheses around all the different terms that you have. And when you multiply by the least common denominator, you can do the same thing. Put it in parentheses and just go back and multiply every single term to go from there. And for the first term, nothing there. 4b is 4b. For this one, your b's will cancel out. You get 40. And then 9 times b is just 9b. Okay. And again, with all these, when you multiply by the least common denominator, you should have just whole numbers left. Now it's just a matter of getting the b's to one side, numbers to the other, and then just work this thing out. I would say since the 40 is over here by itself and you've got the b's scattered, let's get rid of this 4b and move it over to the right-hand side. So 40 equals 5b. Take the 40 divided by 5. B would equal 8. Okay, so for example 5, to make the denominators a little bit more complex. I don't want to say complex, a little bit longer. We'll put it that way, because they're not complex. You just have a little bit more variables to it. So you've got 6 over v minus 4 minus 4 over v minus 4 equals 2. Okay, you've got two options here. You can go ahead, and again, v minus 4 is your only denominator, so you can go back through and multiply everything by v minus 4. But do you notice one little something on this left-hand side? If that equals 2 was not there, what could you do there? Or got common denominators, correct? So just put it together. So go ahead and do 6 minus 4, and just put that over v minus 4. And then 6 minus 4 is 2. And if it's equal to 2, Well, it's okay. Because now you've taken what you had was two fractions, combine it together to make one, and you're still going to do the same thing. You're still going to go back now and multiply by the least common denominator. But now when you do this, you only have to multiply it to one fraction instead of two different fractions. You get the same answer. It's just, in this case, if they give you some like terms that you have here, just go ahead and put those two terms together so you've got one fraction instead of two to make it just a little bit easier. Okay, so then we're going to take the original problem that we've got now, multiply both sides by v minus 4. And we do that one again. The v minus 4s here would cancel. So these with 2 times 1 on the left-hand side, or just 2. Right-hand side, that's just distributive property. 2 times v for 2v. 2 times 4 for 8. And now you've got just a regular equation that you've got to work with here. Well, now we're going to add 8 to both sides, because you still have to get the v by itself. So we're going to add 8 to both sides to get 10 on the left-hand side and 2v on the right-hand side. And then you're going to take 10 divided by 2, find out that v would equal 5. There you go. Number are we on? Number 6. Okay. So let's go with 2 over v minus 5 equals 6 over 3v minus 15 equals, minus 4. Okay, and again, still a little bit different than some of the other ones, but it's still the exact same thing. Before you do anything, now there are no like terms we have to combine, so this one we don't have to worry about that part. But you still got to find your least common denominator, and you have two denominators. You've got v minus 5 for one denominator, you've got 3v minus 15 for the other one. Well, no, it's still going to be one problem. You're still looking for the one denominator that you would have that would cover everything that happens through those two. So you're trying to figure out what they have in common. Now, with v minus 5, it's pretty much done. But 3v minus 15, that's 3 times v minus 5, correct? So for that one, since this is one denominator, and this is our other denominator, we've got to figure out what these two things have in common. And when we take this one and just rewrite it, so it's 3 times v minus 5. Well, now you've got a v minus 5 in your denominator, and you've also got a 3. So you can almost think about this fraction that you've got here really as being this. So when they've got it written with the 3v minus 15, just realize you can factor that denominator. And it goes back to, I guess, the section 1 part of it, that when you had to find the restrictions on the denominator and go through the steps on that one, you factor the denominator as much as you could. Same thing with this one. You factor the denominators as much as you possibly can, and once you factored it as much as you can, then tell me what you got. Now, and here's where you've got two options. And it depends on what you want to see on this one. Question, go ahead. All right, so we've factored this one. We've got this part of it here. We've got the least common denominator, but here's where, again, you can kind of maybe catch something that's here. When we factored this first fraction on the right-hand side, can you simplify 6 over 3? Divide them both by 3, right? So make that a 1 and make that a 2. So if we even go a little bit farther, we've got 2 over v minus 5 equals 2 over v minus 5 minus 4. So now that extra 3 that we had here, we really don't even need that anymore. Now we can just take everything and multiply times v minus 5. Okay, so if we had it back here, we were going to multiply there, but as soon as we had this kind of thing factored out, hopefully you could see that that would cancel. Now, if it doesn't cancel, we'd have to just multiply by 3 times v minus 5. But for this part, we actually got the 3 to cancel out, so now we can just multiply everything by v minus 5. Yeah. Well, if this... Okay, we're holding right there. Alright, so we got v minus 5 equals 2 over v minus 5 times v minus 5 minus 4 times v minus 5. Yes. And then you'll cancel out everything that you can cancel out there. Okay, so, and again, the fractions should go away. Those v minus 5s will cancel. Leaves you with a 2. These v minus 5s will cancel. Leaves you with a 2. And this was a whole number. And again, here's where you have to be just a little bit careful because it is negative 4 times v minus 5. It's negative 4 times v, and it's negative 4 times negative 5. So that's a negative 4v. Make sure you put the plus 20, because sometimes that plus will kind of stick in on you when you go through those. Okay. Now, here's the thing. You've got the v's on this side, so let's leave that one where it is. Let's get rid of the 2's and let's get rid of the 20's, move everything up over the left-hand side. And one small thing you can do, we've got the 2 equals. Since you have 2 plus 20 over here, go ahead and put that together and make it 22. So you've got 22 minus 4v. When we did the distributive property with the negative 4. Yeah, that when we combined it here, we're putting these two together to get that 22. Okay, and now that you've got those two together, now it's just one number on the right-hand side. That's the number we need to get rid of. So let's get rid of that 22 and let's subtract 22. Move it over here. And when you take negative 20, divide it by negative 4, v would equal 5. Okay, now here's one little thing they added to this one. They added in the directions. They still solved for this one. They added one little extra thing in the directions. It says if there is no solution. It says click no solution without a click, but we're going to go ahead and say it that way. It says click no solution. Yeah. Okay. Yeah. So now here's the catch with this one. We do have an answer, but this is our answer that we had of we can get rid of all the traffic or 99% of traffic fatalities if we only do a speed limit of 10. Correct? Right. This is one of those they're telling you, all right, check this answer and make sure it actually works because yes, we've got a solution, but is it really going to work? So this is where we go back to the restrictions part, and this is one to me the question should have been worded a little bit different. They should have said solve for V and state your restrictions so that you know you're looking to see that you've got to check this answer. So for this one, you're going to take the V minus or the V equals 5, and you've got to go back and plug it back into the original problem, and you've got to check it. You've got to check your solution. Because what happens when you take that V equals 5 and you check it and you put that 5 right here? That's 2 over 0. So you get 2 over 0, correct? Right. That's undefined. That is not an answer So that's one of those problems where, yes, we got an answer, but when they tell you, go back and check and go through those, you got to go back and check. So this one actually would be a no solution kind of problem. So for these, you've got to check, let's say it this way, you've got to check in the original.
So scroll back up to
The numbers with it a little bit. Is this number 7? Okay. Let's go with 4 over x plus 4 equals 8 over 2x plus 8 minus 3. Okay, in the two denominators you have an x plus 4 and you have a 2x plus 8. Okay, and for this one, when you have the x plus 4, there's nothing you can do. That denominator is locked in. There's no way you can change it. But with 2x minus 8, we can change that one a little bit, right? Because the 2 and 8, we can divide them by 2. So we can rewrite that one as 2 times x plus 4. So when you're doing this problem, before you do anything at all, because and kind of going back to what we did back in the first part of chapter 7, is that when you're finding the restrictions, you factor the denominator as much as you possibly can. So if we were looking at restrictions on this one, this is really what you would want that denominator to look like. Because all you're doing is taking this 2x minus 8 and rewriting it as 2x, or 2 times x plus 4. Okay, and you have two options. You can either go ahead and multiply everything by 2 times x minus 4 and solve that like a normal problem. Or, you've got 8 over 2 for this one, correct? So let's take this 8 and this 2, divide them both by 2, and that's 1 and 4. So really, this is 4 over x plus 4 equals another 4 over x plus 4. So that now we've factored out the 8 and the 2. Now we've got down to just two fractions, and both of them have the same denominator of x plus 4. So now let's multiply everything by x plus 4. Okay, so we're going to take everything here, multiply it by x plus 4. Scroll it down just a little bit. And another x plus 4. Okay, so we had the original problem that we had. We set the denominators equal to 0, or we factored them out, try to get everything here. This canceled. So really, this is like a new problem that we've solved that's a little bit easier because we only have one denominator to worry about now. That's x plus 4. And when you multiply, those cancel, and those cancel. So you have 4 equals 4. And again, the only thing you really have to be careful of on this back end is that it's negative 3 times x, and it's also negative 3 times 4. So that's a negative 3x and then minus 12. Okay, and either you can do this a couple of different ways, but on the left or the right-hand side, you've got the 4 minus 12. Since they're on the same side, just do 4 minus 12. And make that negative 8. And then the minus 3x is just going to hang out behind it. And now we've got whole numbers. Don't have to worry about fractions. The x is already by itself, so let's move the 8 over to the other side. So we'll do plus 8. So we've got 12 equals negative 3x. But when you take 12 and divide by 3, we get to negative 4. Now, and again, they tell you on this one, they give you that hint of, because some of the earlier problems, they didn't mention anything at all about clicking if there's no solution. This one, that's in the directions that if you get an answer that's no solution, click no solution, which basically says, check it. Does it really work? And if you go back to the now, when you check it, you have to go back to the original problem. That was 4 over x plus 4 equals. Now, we can do the rest of it, and we'll go ahead and do that so we don't lose anybody. Yes. Well, for this one, we went back and divided by negative 3.
Right.
Yeah. So that would cancel out and give us a positive x, and then 12 divided by 3, negative 4. If you take the negative 4, and plug it in, that's 4 over negative 4 plus 4, which is 0. Doesn't matter what happens on the right-hand side. This is 4 over 0. That's undefined, which means that solution doesn't work, so this one has no solution. Okay, so that's when it says check your solutions, click no solution if it's there. That just means you've got to check your answer. I mean, you could almost look at, too, is that you're doing the restrictions in the beginning. That you could almost say, all right, here's the restrictions I have. Does this answer fit the restrictions? And if we did that, negative 4 would be the answer that we could not use for this thing. Eight? Okay. It was short, too. We had a lot of questions. So, yeah. Okay, so this one starts off with the same thing. We're going to solve it for whatever the variable is, u in this case. It says if there's more than one solution, separate them with commas. It also says if there is no solution, then click no solution. So they kind of give you that heads up of, okay, you're going to get an answer. You've got to go back and check the answer because there's a possibility that it may not really work with the situation that we're doing here. Okay, so for this one, we've got to find the least common denominator first. And you have u squared minus 16. You've got u minus 4, and you've got u plus 4. Okay, so yes, so the very first fraction we've got here is u squared minus 16. That's the difference of perfect squares, so that's u plus 4 and u minus 4. So and it's almost one of those that as soon as you do that, you can go back to the original problem you have, get rid of that, and rewrite that as u minus 4 and u plus 4. And if you do that, what's all the different things that show up in the denominator? U minus 4 and u plus 4, right? So that would be your least common denominator, would be u plus 4 and u minus 4. Oh, that we took the u squared minus 16. If you can factor it, you factor the denominator as much as you possibly can. And when we did that, it actually wound up being these two things, so it just repeated itself a couple times. Okay, so now that we've got the least common denominator, and we know it's u plus 4 and u minus 4 because we factored this one off. Now we're going to go back and multiply everything by that least common denominator. And the only thing we're going to do just a little bit different is that for this first fraction, instead of writing it as u squared minus 16, just go ahead and rewrite it as u plus 4, u minus 4. Because that's what it was when we factored it, so let's go ahead and put that part of it in there. Okay, so that was our original problem we had. Here we're going to multiply by u plus 4 and u minus 4. And that was equal to, it's minus 6 over u minus 4 times u plus 4 and u minus 4 equals, and I have to squeeze this one in a little bit, 1 over u plus 4 times u plus 4, u minus 4. And let me scroll that down so we can see it a little bit better. Okay, so everything in black was the original problem. The red is our least common denominator, where we took all three terms we had and multiplied it by the least common denominator. Now, and again, when you do this, every single time, you should not have any fractions after you multiply by the least common denominator. Everything should be gone. It should be just whole numbers. That for this one, that u plus 4 cancels that u plus 4. That u minus 4 cancels that u minus 4. The next one, that u minus 4 will cancel that one. We're left with the 6, and we'll pull that down in a second. And on the right side, this u plus 4 will cancel that u plus 4. Okay, and then everything that's left. We canceled everything here but the 6, so the 6 is all by itself. You've got a minus 6 and a u plus 4. Equals, we've got a 1 times u minus 4, and really if we're doing times 1, that's not going to change anything. Okay, and again, when you're doing this one, because the minus and the 6 that's here, realize that it is negative 6 times u, and it's negative 6 times 4, so this will be minus 6u minus 24. The sign in front always goes with that number. So when we have the 6 here, the negative or the minus goes with it. The right-hand side, it's just 1 times that, so that doesn't change anything. That one is just u minus 4. Okay, and we got to jump to the next page because I'm at the bottom of the page here. So let me bring it back up. So 6 minus 6u minus 24. What was the right-hand side? Was it u minus 4? Okay, so that's what we have. Now, and one little thing you can do if you want to, because that's one, it's u minus 4, sometimes it helps just to think that that's 1 u minus 4, because there is 1 u that's there. So when we start adding, subtracting, moving terms around, sometimes it's just helpful to have that 1 in front. The left-hand side. Now, you do have 6 minus 24 on the left-hand side, so go ahead and put those two together. And if you do 6 minus 24, that's really a negative 18. The negative 6u is there. We've got the 1u minus 4. And we've got to start moving things one side to the other. And again, I like to get rid of the negative, so if you've got a negative 6u, let's add 6u to both sides. Because it's easier to add than it is to subtract for most people. We've got the negative 18. That's going to equal 7u minus 4. So now the u's are the right-hand side. We've got to get rid of this 4, move it over to the left-hand side. Let's say negative 14 equal to 7u. Divide those two, so the u would equal negative 2. Good. Now, and you have to check. Now, here's the good thing when you check it. If you think about the least common denominator, whatever we used for the least common denominator, which was u plus 4 and u minus 4, that's really your restrictions. If that answer comes out equal to 0, so when you go back to start checking this one, that's your restrictions that you can't have. If you check this one, that means that u cannot be negative 4 and u cannot be positive 4. Any other answer, we're good. So with this answer being negative 2, if we check it, it's fine. So And if you want to do it that way instead of having to go back and plug it back in, when you get to the answer, if you'd rather do it that way, just realize that the restrictions that you're going to have, it's whatever you use for the least common denominator set equal to 0. And that's the answers you cannot have. You cannot have 4, and you cannot have negative 4. Any other answer, you're good to go. And if you'd rather do it that way than what we did back on the earlier page, because back here, I'll go back one more. We could do the same thing without actually having to check it, that when we got to this one, we used v minus 5 for our common denominator, that when we get this answer, we could have put right here that the restrictions are the least common denominator equal to 0, and the least common denominator was v minus 5. So if we solved that one, we would have had the restriction was that v equals 5. And as soon as we had that, we didn't have to plug it back in. We could say that one's got no solution. So that might be easier than having to go back and plug it back in. If you'd rather plug it back in, you can, but that's one little small thing you can do that might speed this problem up a little bit instead of having to go back and actually check it there. Yeah. Yes, that answer would be negative 2. Because that negative 2 wasn't on our list of restrictions. Okay, let's get you one a little bit shorter. How about that? Let's go 5 over x equals x minus 4 over x. Or at least I think it's shorter. Hopefully it'll be that way. And it's still got those same directions. Separate the answers with commas if you have it. And it's also going to say the thing about the no solution. Click no solution, blah, 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 all that other stuff. So it's giving that exact same thing. If you have more than one answer, you got to separate with commas. If you have no solution, you got to click no solution. So that's still in those. And again, the first couple of problems, it didn't list that, so you didn't have to worry about checking the answers. But once that pops up, you have to kind of think about what those parts would be. Now, here's the part that makes this one go a little bit faster. What is the only thing in the denominator? X. That is your least common denominator, correct? So the least common denominator has to be x. And if you want to right now, you can go ahead and do your restrictions. Because if we're going to use x for our least common denominator, that's also our restrictions. And if you set x equal to 0, that means, well, that's it. Because there's nothing to add or subtract x, so there's our least common denominator. Our restriction is we cannot use 0. So if 0 is the answer, we chunk it out, it doesn't work. Okay, so easy way to check it there at the beginning of it. All right, so we're going to take everything here, multiply it by x. And we'll put that x in parentheses. Yes, we do. Okay, so for this one, the least common denominator is easier because there's only one thing in the denominator. So multiplying 3 by x, shouldn't be too bad. So these x's will cancel. These x's will cancel. So you have 5 equals x squared minus 4. Okay. Now a little bit different on this one, but maybe not too bad. Instead of it just being x, this time it's x squared, and it's just x squared in numbers, so we have to get the x squared by itself. So we're going to add the 4 to both sides. Okay, so we've got 9 equals x squared. Now, here's the catch with this one. We're solving an equation that's x squared, right? How many answers we got to have? Got to have 2. So when you start solving the equation, everything else we've done so far at this point, we had x. We were looking for one answer. Now that we're solving this equation for x squared, we got to have 2 answers. And if x squared equals 9, perfect squares, right? So you can square root 9. Yeah, that basically, if you, now did we talk about doing square roots on both sides? Okay. All right, so here's what they did. Because sometimes they do, and here's where they kind of show two options. If you've got x squared equal to a number, of course, 3 times 3 squared would equal 9, correct? Everybody okay with that? At the same time, you could do negative 3 squared equal 9. So, because if you do a negative times negative, that's positive. So for that one, that would be your two answers. Is that if you plug in 3, you get negative 3. Now here's kind of what they do for this one. Because again, I'm kind of thinking back to with the factoring that they had done this. That you could have moved this negative 5 over here. So you have the difference of two perfect squares, and then you could factor this off as x plus 3 and x minus 3. So if you'd rather go that route with this one, we'll go that route. Well, this one will be negative 3. Yeah. We need negative 3 and positive 3. Yep.
So you could write it that way, or would you write 3 squared? Because it gives you a
No, you would.
the square in the.
No, it should be just 3 and negative 3. Because technically on this one, what I was going with, and I was thinking of something else, that if you get x squared and knock it down to the x term, you square root both sides.
Right.
And if you square root 9, that would be 3.
Right.
When you squared x squared, that would be x. But because you need two answers, they say, all right, well, what you're going to do is you're going to put a plus in front of it, or you can put a minus. So the x could be positive or negative 3. And there's your plus and your minus. So, yeah. So,
For Alex,
but yeah, you need this for Alex. You got to have 3 comma negative 3 or negative 3 comma 3. Which one you put first, it doesn't matter there. Okay, so that one, a little bit easier, denominator. The only difference was, again, and that's the key thing you got to watch out for, is that if this is x squared, you got to have two answers. If it's just x, you just need one. So that's one thing you can kind of do when you go through these problems. And that's how, when it talks about, separate the answers with a comma, when you start solving, that's the way to know how many answers you need. If you have x squared, you got to have 2. If you just have x, you're just going to have the 1. All right, 2 more examples, and then we'll take a little break here, because we're almost there. Well, actually, let's take a break right now. All right, for example 10, same questions, still solving. It's still going to tell you if you have more than one answer, separate it with commas. If you have no solution, click no solution. So it's still that once you get past the first few problems, every solving question, it's going to be the same kind of steps for this one. And it's still that same thing. You're still going to find out what the least common denominator is. And this one should be a little bit easier because you only have 2 denominators. One of them is v plus 1. The other one is v plus 2. There's nothing you can factor out of those 2, so that has to be your least common denominator. There's no factoring. There's nothing with this one. You've got 2 totally different expressions here, so that would be that part. Now, here's one where, again, if you want to go ahead and do your restrictions now, you can find out what the answers are that you cannot use. And to find the restrictions, you just set everything in your least common denominator equal to 0. So you're going to do v plus 1 equal to 0. So that's v equals negative 1. You're also going to do v plus 2 equal to 0. So v equals negative 2. Okay, so you can go ahead and kind of put that one on the side there for a little bit, that if you get negative 1 or you get negative 2, neither one of those 2 answers work, so if those pop up, you have to get rid of them, and that will not be an option that you can do for this part. Okay, so now we're going to go back to the original problem we've got. Now that we know what the least common denominator is, and you could do that on the earlier problems that we did before, that as soon as you've got your least common denominator, set that equal to 0, and if that's your answer, you have to get rid of it. That's just the way it comes down to it. So what we're going to do is we're going to take everything here and we're going to multiply it times v minus 1, or v plus 1 and v plus 2. So we're going to take the 8, multiply it times v plus 1 and v plus 2. Minus 3 over v plus 1 and that's times v plus 1 and v plus 2. And that's going to equal 3 over v plus 2. Okay, so taking the 8 minus 3v, or minus 3 over v plus 1 equal to 3v plus 2, multiplying every single term by the least common denominator, and work it out and see. And again, this fraction, that v plus 1 cancels that v plus 1. That v plus 2 cancels that v plus 2. So you're left with a negative 3 times v plus 2 equals 3 times v plus 1. Now, and in the first part, you've got 8 times v plus 1 and v plus 2. There wasn't anything to factor, right? Nothing to cancel. So for this one, we've got to multiply all this together. And for the v plus 1 and v plus 2, you have to do the full method there. And if you do the full method, you get v squared, because you're going to do v times v. Then you're going to do v times 2. 1 times v for 1v, and then 1 times 2 for 2. Now, and the 8 was out front of this thing, so when you do the 8 here, it's still 8 out front of that whole thing. And on the inside, you can take the 1v plus 2v and make that 3v. And we still haven't done anything with the 8 yet, so now you're going to do 8 and do distributive property with that 8 through these. So now you're going to have 8v squared plus 24v plus 16. Okay, so we've done the full method, did 8 times all this, and gotten this from that very first part. The second part here, you got negative 3 times v, and then negative 3 times 2. So that's a negative 3v minus 6. And then one more distributive property on the right-hand side, 3 times v for 3v, and 3 times 1 for 3. Okay, so least common denominator, fairly easy to find. When you go back and multiply it out, you do get the part that cancels. This is the one where it gets a little bit more difficult because you have to do the full method to get this part simplified. And when you've got, now we've got v squareds, we've got v's, we've got numbers. This is one of those where you have to bring everything to the left-hand side with this v squared, and then we're going to put all these terms together that's over here. Before we do that, we've got 24v minus 3v. So let's go ahead and make that a 21v, and that was positive. And we'll leave the 8v squared there. So we did 24 minus 3 to make that one, and then we've got the the positive 16 plus 6. 16 minus 6, and that would be a plus 10. Still got 3v plus 3 on the right-hand side. Okay, now we can move stuff to the left-hand side. You've got my plus 3. Let's go minus 3. Now, and you can do these, do it one piece at a time, but since we're going to also move to 3v, let's go ahead and get rid of that 3v and subtract it at the same time. So we can move everything all at one time. So we're moving the 3 over here. We're also moving the 3v over here. So it's going to be 8v squared. 21 minus 3 is 18. 10 minus 3 is 7. That's going to equal 0. And we'll pause right there for just a second. Let everybody get caught up. And with the exponent of 2, looking for the 2 answers. So here's what we have to do for this one. We're going to have to factor this one because we start with v squared. And this is right at the bottom of the page, so before we do that, let me just take this over to the next page. So we've got 8v squared plus 18v plus 7. Now, the good news on this one is it's all positive, so we don't have to worry about any negatives when we're going through this one. The bad news is the first term is 8, so when we do this one, we have to start with 8 times 7, doing the AC method. 8 times 7 is 56. So we're looking for the factors of 56, where the sum would equal positive 18. And again, the good thing on this one is they're all positive, so we don't have to worry about any negatives. So we're looking for the numbers that's going to add up to 18. We've got 1 and 56, could be 2 and 28. 3 doesn't go. 4 would be 14. And we don't have to go any farther because if you add 4 and 14, that would be 18. So this was V. So that's V plus 4 and V plus 18. Now, the one catch on this one is, again, because we had to do the AC method in the beginning, that because we multiplied by 8, now to even it back out, you've got to go back and divide by 8. Oh, 14. Sorry, my bad. Thank you for catching that. Okay, and now we do have some simplifying you can do, because 4 over 8, that's a half. 14 over 8, divide them both by 2, that would make it 7 over 4. Simplify the fractions as much as you can. We didn't have any whole numbers, so here's where you get to do the bottoms up method. Pull the 2 up in front of the V, make it 2V plus 1. Pull the 4 up in front of the V and make it 4V plus 7. Okay, and you're going to set both of those equal to 0. Okay, now here's where you can kind of, hopefully maybe cut the work down on yourself just a little bit. Here's something else you can kind of notice. Because this one, you're going to subtract 1 and then divide by 2. So you can work it out, but if you just think about it, here's the other shortcut. Notice how this was V plus a half equal to 0? If you want to set that equal to 0, wouldn't you just subtract a half? So V would be negative 1 half. Whether you can go straight from here to here, or if you need to rewrite it and do the bottoms up, that's fine. You know, if you've gotten used to doing the bottoms up and want to stick with this method, then just go ahead. You know, so this one you would subtract 1, and then once you subtracted the 1, then you go back and divide by 2. This one you would subtract 7, and then you would divide by 4. So V would equal negative 7/4. This one, the restrictions we had were negative 2 and negative 1. Those obviously aren't negative 2 and negative 1, so that would be your two solutions. And again, if you're putting that in on Alex, you would put negative 1 half and then comma negative 7/4. Okay, for the last one here out of section 6. 16u squared over u squared minus 1 equals 10 over u minus 1 and then 17 over u plus 1. Now, here's one where, you can almost kind of set yourself up because you've got a u minus 1 and a u plus 1. This is the difference of two squares, correct? So for this one, you can almost go ahead and think about this denominator as being u plus 1 and u minus 1. Okay, which hopefully should make it a little bit easier, because now, what do you have in your denominators? U plus 1 and U minus 1, right? So now that you factored this one off because it was a difference of two perfect squares and rewritten it here, well, now you can multiply by your least common denominator, which is U plus 1 and U minus 1. Because that's the only thing that's in your denominators. Now, and again, restriction-wise, if you want to worry about the restrictions, you've got them right here, because you're just going to take both of those things equal to 0, and if you do that, if you do U plus 1 equal to 0, and U minus 1 equal to 0, well, you're going to have positive 1 and negative 1 for your restrictions. So if we get negative 1 or positive 1 for the answer, you've got to throw those answers out and not use those two. Okay, so let's take this fraction we've got here, multiply it by U plus 1, U minus 1. Okay, so it takes a little bit of time to get through the setup there. And somebody was asking earlier about the test. They said, well, a lot of these problems are longer. We're going to have a lot of those. No, the long problems, you won't have tons of those. So it's more of, again, there are 47 objectives in Chapter 7. You've got another 16, or how many it was, 10, and that one, 57 objectives. The test is going to be 25 questions or so. So we're only really going to get to hit half of the objectives when you go through those. So you're not going to have multiple questions from one objective. There's just too many objectives we have going through those. Okay, so we've got everything here. Just start canceling everything out, and let's see what we've got left over. Get rid of the U plus 1 and U plus 1. Get rid of the U minus 1 and the U minus 1. U minus 1 here and a U minus 1 there. A U plus 1 there and a U plus 1 there. So on the left-hand side, we've got 16u squared. We have 10 times u plus 1 plus 17u times u minus 1. Okay, left-hand side. Everything cancels, left us with a 16u squared, so there's nothing to worry about for that side. The right-hand side, though, you do have 10 times this, so 10 times u is 10u, and 10 times 1 is 10. You've got 17u times u, which would be 17u squared, and then 17u times negative 1 will make it a negative 17u. Okay, and when we're solving equations, you're pretty much going to move everything to one side. And since most everything is over here, let's just move the 16u squared over here and then combine like terms. Now, if you want to, before we move it over, you do have a couple like terms. You've got 10u minus 17u that are on the same side. So go ahead and do 10u minus 17u to make that negative 7u. And we almost always want that u squared term first, so let's put that u squared term first. So let's put the 17u squared here. And then we've got the plus 10 in the middle of this, so we'll put the plus 10 over here. Okay, now there's only one thing to move. Let's get rid of the 16u squared and move it to the right-hand side. So that's 0 equals u squared minus 7u plus 10. And two things you're looking for. U squared. So we're looking for two answers. And with this one, if it's u squared, then that means we're going to have to factor this thing. And the good thing is the first term is just 1, so we don't have to worry about doing the AC method. We're just looking for the factors of positive 10, where the sum is going to equal negative 7. And with 10, you only have two choices. It's either 1 and 10 or 2 and 5. Well, there's no way you can get 7 from 1 and 10, so it's got to be 2 and 5. And since the b term is negative, that's got to go with the bigger number. And if you do a positive divided by negative, it means the 2's got to be negative. Okay, so that one. Factoring was easier at the end because we didn't have to do the AC method. So now we're going to set both of those equal to 0. And setting those equal to 0, we get u equals 2 and u equals 5. And what was our original restrictions? Positive and negative 1. So that one we're good. So those weren't in the restrictions, so both of those answers are good. And again, for the ALEKS, they like the answers written as 2, 5.